uh, the class now. Spanning tree. So what is a span? In the last class, in the last lectures, we learned about the trees. Now next we are going to discuss a spanning tree. What is a spanning tree means? A spanning tree is a spanning tree is a simple graph is simple graph G spanning tree of a, wait a minute, spanning, spanning tree, mute yourself, spanning tree of a simple graph. First I am going to give the definition, then we will discuss detailing. Spanning tree of a simple graph G defined by a subgraph defined by a subgraph containing every vertex of G. So now this is a definition of the spanning tree. Spanning tree of a simple graph G defined as a subgraph containing every vertex of G. So what its meaning means, first we'll come to the what is a simple graph. I already in the starting class many times explained. For example, you take one graph. This is a G is a graph. This you called as a simple graph. It is a simple. So now, which is not simple means, for example, when you take like this is a not a simple graph. It is not simple. So from this example, what you observed, no multiple edges. No multiple edges is nothing but the simple graph. If you have the two vertices, the multiple edges, then it is not a simple graph. So that is nothing but a spanning tree is a spanning tree of simple graph is defined as a subgraph containing every vertex. That means the spanning tree will be derived from simple graph, not from this type of graph. So we remove this graph. Okay. So now this is one simple graph. For this simple graph, you take one subgraph. For the simple graph, you take one subgraph which contains every vertex of G. For example, this has a B, C. A, B, C. This is one simple graph. For this graph, you take one subgraph which contains the every vertex of G. For example, I am taking like this. This is a subgraph A, B, C. Is contains all the vertices of given graph G? Yes. Therefore, it is a spanning tree. This is a simple graph. From the simple graph, it's a subgraph. Remove one edge. I am removing one edge. For the given graph, you remove some edges. Whatever you got, that is called as a subgraph. Not only edges, you can remove vertices also. So that is called as a subgraph. So spanning tree means spanning tree is derived from the simple graph. This is a simple graph. From the simple graph, you take one subgraph which contains every vertex of the given graph. So the given graph has a, hello, who is that? మీరు ఇలాంటి నేను కొంచెం మర్చిపోతే మీకు మీ ఇష్టం వచ్చింది చేస్తారా? ఓకే, don't make any unnecessary thing. Sorry, I'm actually recording this class for your purpose. మీకు మళ్ళీ సెండ్ చేయడానికి. మీరు unnecessary things చేయకండి. నేను ఇక్కడ నుంచి ఓకే ఐ డిజేబుల్డ్. నేను కొంచెం మిమ్మల్ని మర్చిపోతే మీరు మీకు ఇష్టం వచ్చింది చేస్తారు. సో now, so this is a simple graph. From the simple graph, you take one subgraph. That subgraph contains every vertex of G, A, B, C. All the vertices of the given graph is there. Therefore, it is a spanning tree. It is a spanning tree. Okay. So now we take some more examples. So now I explained many times, don't do any such a things which is a disturbance for others. And not only this, I'm trying to record this all classes for your future purpose. మీకే కాదు తర్వాత మీకు వచ్చే స్టూడెంట్స్ కూడా యూజ్ అవ్వాలని ట్రై చేస్తున్నాను. మీరు అన్నెసరీ థింగ్స్ చేయొద్దు. నియర్లీ ఇన్ మై యూట్యూబ్ ఛానల్ 3000 views are completed. All the whatever the classes for first year, some second year. This also very soon I'm uploading. So now example for the spanning tree. For example, take one graph and we take one graph A, B, next C, D, E, F. This is a graph. For this is a G graph. For this G graph, you have to find the spanning trees. So now first you check is a simple graph or not. You check it. Any two vertices, is there multiple edges? For BC, is there multiple edge? No, single edge only. For BD, is there any multiple edge? No. DE, is there any multiple edge? No. EF, any multiple edges? No. So therefore, it is a simple graph. G is a simple graph. For this simple graph, we'll find the spanning tree. So what is the spanning tree? From the given graph, for the given simple graph, you take one subgraph which covers all the vertices. You take one subgraph which covers the all the vertices. For example, one A, A2, B, okay. Next B2, D, D2, E, E2, F, A, B, D, E. This is some C. It is a subgraph. It is a subgraph of the given simple graph. It covers all the vertices. Therefore, it is a spanning tree. Spanning tree. Okay. If you want one more, so A, B, A, B, D. You remove any other edge. For example, A, C, C to E, next E to F, next D, A, A, B, C, next D, next E, next F. I removed this edge. So this is a one spanning tree. So that means for the first one, there is a all vertices covered. Therefore, it is a spanning tree. The second one also covers all the vertices. Therefore, second is also spanning tree. Okay. So now in this way, we can derive the number of spanning trees for the given graph. You don't expect only one spanning tree. It has a many spanning trees you can get for the given graph. Not only these two, we can write, we can derive some other also. So like this, for example, this one, one more spanning tree for the given graph, 3, A to B, next A to B, next B to D, okay, D to E, okay, E to F. You can add like this, C. So this is a one spanning tree. It is covering all the vertices of the given graph. Therefore, this is also spanning tree. These are all the spanning trees for the given graph, simple graph. Whatever the 1, 2, 3, 4, all are the, sorry, 1, 2, 3, all are the spanning trees for the given graph. So this is about the spanning tree definition. One more time I'm saying, a spanning tree of the simple graph G is defined as a subgraph containing every vertex of G. For this given simple graph, you draw one subgraph which contains the every vertex of the given graph. Anni vertices undali. Unte danni emantaru spanning tree antaru from the given graph. Okay. So now when you are discussing the spanning tree, you have the number of you are getting the number of spanning trees for the given graph. Now the question is there any methods to find these spanning trees? Is there any method to find the spanning tree? Means yes, there is a two famous methods will be there. One is called as a BFS to find a spanning tree. To find spanning tree for given graph G, we have two methods. We have two methods. Okay. First one is called as a BFS. Second one is called as a DFS. Okay. That will discuss what is a BFS and DFS. So this BFS is nothing but breadth first search. DFS is a depth first search. Okay, these methods we will discuss now. Okay, so now say mute yourself. So now we are coming to BFS method. BFS method to find spanning tree. Okay, so in the BFS method, what you have to do means first step, you choose one vertex arbitrarily. You choose one vertex. Second, what you have to do means whatever the edges incident to it, add them. Choose one vertex. The second step, add edges incident to it. Okay, ఒక వర్టెక్స్ తీసుకొని ఆ వర్టెక్స్ కి ఎడ్జెస్ ఏమేమి ఎడ్జెస్ ఉన్నాయి, యూ హావ్ టు యాడ్ ఆల్ దట్. సో దట్ ఆర్ కాల్డ్ యాడ్ ఎడ్జెస్ ఇన్సిడెంట్ టు ఇట్. whatever the vertices in this level are called level 1 vertices. Level 1, whatever the vertices in this level are called level 1. So in the level, next what you have to do means for the level 1, whatever the vertices is there, you add all the edges. First choose one vertex. Second, add edges incident to it. For that vertex, for example, you are selected a vertex. What are the edges is there, you add all them. So when you add all them, for that there is a corresponding vertices will be there. So that are all vertices are called as a level 1 vertices. For the level 1, again what you have to do means for level 1, add all edges. So when you add all edges, you will get level 2 vertices. When you are adding this, you remember that not to form cycle. Cycle means closed one. It does not want to be the circuit. Cycle or circuit. It does not want to form the closed loop. Form kavadu. So when you are adding the edges, you remember that it does not want to be form the closed loops. Closed loops are called as a cycle, circuit. Okay. So now this is about the BFS method. First we see the example detailing. First choose one vertex. Second, add edges incident to it. Whatever the vertices in this level you got that are called level 1 vertices. For level 1, add all the edges, you will get the level 2 vertices. When you are doing this process, it does not want to form the cycle. Cycle means a closed loop, does not want to be formed. So now we see one by taking an example problem. So find question, find spanning tree, find spanning tree for the following simple graph, for the following simple graph. Mute yourself. For the following simple graph. Okay, so now the graph is A2, this is some A2, G, B, next unmute. I'm giving unmuting chance to you. Why? Because if anyone have the doubt, they can rise. That's the reason. Otherwise, permanently I can mute by here only. మీకు మళ్ళీ ఎవరైనా ఏదైనా మాట్లాడాలనుకోవాలని చెప్పి అన్మ్యూట్ మీకు ఛాన్స్ ఇస్తున్నాను. డోంట్ మిస్యూజ్ దట్. Okay, I'm taking one graph. For this you will find the spanning tree. You can expect like this question in the final exam compulsory. A, B, C, F, E, next G, A, B, C, D, E, F, G. Now, this is a graph. For this graph, you have to find the spanning tree by BFS. Find spanning tree for the following simple graph by BFS method. Okay, very simple. Listen here. First, what you have to do means select one vertex. Select one vertex. So choose. I'm choosing A. Your choice, you can choose anyone. So I'm choosing A. Next, step 2. This is a solution. Step 2. Step 2, what you have to do means add all the edges that are incident to A. Add all edges that are incident to A. So what are that they? For example, in the first step I selected A vertex. Second step, this is A vertex. Add all the edges. What is there? A to D is there, added. Okay. Next to A to G is there, added. Next to A to E is there, A to E is there, added. Is there any other edges to add it to A? No. A to D is there, added. Next to A to G is there, added. Next to A to E is also there, added. So what is the level 1 vertices now? Level 1 vertices are, what are that? D comma G comma E. These are the level 1 vertices. For this level 1 vertices, you add again edges to it. So you can add in such a way it does not want to be formed the cycle. Cycle means closed loop. You can add. If you are getting closed loop means you don't add, you remove that edge. Okay. So like that you cover all the vertices. So now we are added. What are that in the second step? You got D, G, E. Next, in the third step, listen here. Third step, otherwise we do here only. I'll change the color. For third step, add the edges that are incident to D. Add this one, what will get? D to C. Okay. Next, after that, D to C, we are added. D to any other edge will be there. yes is there, D to G. But if you add D to G, what is happening? It is forms a cycle, so you don't add. D to C added. If you add D to G, it forms a cycle, so skip that edge. Next, come to G. When you come to G, add another vertex. What is that one? B is added. Next, G to E is there. If you add G to E, what will get? It forms the closed loop. So don't add G to E. So don't add G to E. Next, E2. Next, if you add E to B, E to whatever the edges is there, that all you add. Suppose if you add E to B, it forms a cycle. So you don't add. Okay. So next, E to F. Can I add E to F? Yes, I can add E to F. So it does not forms the cycle. So now you check it. Is all the vertices covered or not? How many vertices? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All the vertices are covered. Therefore this is a spanning required spanning tree. So that means how we can write means, for example, we can write the same color. I'll drop this one. So what is our answer? Answer is required spanning tree. What you got? First, A to G, G to B, next A to D, next D to C, next A to E, E to F. So this is a required spanning tree. So it covers all the vertices. This is our answer. Okay. You have to do this. Step 1, choose vertex. Step 2, add all the edges that are incident to A. Whatever I red marked, that you do in the next step by taking. Again, draw this side, you draw step 3. Like that we can do, we can find the spanning tree for the given graph. This is called as a BFS method. So first to choose a vertex. Second step, all the edges incident to it, A, add them. Third step, second step, what are the vertices that the what E, G, D are called level 1 vertices. Level 1 vertices, again you add the edges. Okay. So it does not form the cycle. So repeat this process until to cover all the vertices. Until to cover all the vertices. Okay. Is there any doubt?
No, sir.
Okay. So next we will discuss the DFS method. Before that, we try to do one more example. We have the 4 minutes. In that 4 minutes, we try to do one more by BFS. By BFS, find spanning tree. It is a B, G. Otherwise, you take paper and draw C. Next H, D. Next E. Okay. Next F. Next J, I, J, I, K. Next H, N. Next H. This is a I. This is a L. Okay. If you want by BFS method, first take A vertex. Okay. For the A vertex, first add the edges. A, what are there? BG. Okay. Next, I think next B, for BG are the level 1 vertices. B add C, G add, what is that, L. You can add H, G also H. Okay, LHC are the level 2 vertices. Okay, don't add C to H, it forms a cycle. Okay, this is a M. Okay, now what is this M? Again M add, this is a H. Again M add H, add M. Okay, next C, is there any? No. Again H add I. It does not want to form the loop. Again I, new level. For I add D. For I add M. Okay, for I add J. Okay, so these are the, what is this one? For I, this is a D, M, J are the new level. Okay, next for D add E. Don't add EJ, it forms a cycle. Next J add K, next level. So MJ don't add, it forms a cycle. Next E add F. So this is a, it covers all the vertices. So therefore it is a spanning tree. It is a spanning tree. So like this, we can draw the spanning tree. Actually, there is only 2 minutes left. I show within a very short time. When you are doing on the problem on the paper, step 1, choose vertex A. Step 2, add the vertices, add the edges incident to A comma B, A comma G are added. Next level vertices are the B comma G. Next B comma G, add the next edges L, G comma L, B comma C. Next level vertices are the CL, add C to G, add H. Okay, next level vertices are the CHL. For H add J, H add M. Like that you have to do all the things step by step. The meeting is going to be disconnecting within a minute. So everyone again rejoin. We are going to discuss the DFS method. సో ఇప్పుడు ఎంతమంది ఉన్నారో అంతమంది లాగిన్ అవ్వండి. మీకు వింటే చాలా సింపుల్, ఈజీగా అయిపోతుంది.